Did you know that you can treat your entire operating system, your computer, like a SQL database and query it using SQL? I didn't. What if I then told you you can get all of that data out via an OpenTelemetry collector and into your observability system? It's possible. Let's have a look. The first thing you'll need is to download the tool, and it's called Osquery. So go ahead and download Osquery from osquery.io and make sure it's in the path so you can actually call it. Then go ahead and write Osquery I for interactive, and you're dropped into a SQL terminal. So I can do .tables to have a look at what's available to me. I can, for example, look at the USB devices on the system. I can look at the time or the temperature sensors, the users, the uptime, lots and lots and lots of different stuff. Let's have a look, though, at a table called battery. So if I write .schema battery, okay, it's got a manufacturer, a model, a serial number, a cycle count of the battery. That's pretty cool. I can tell how many times my battery's been charged. The state, whether it's charging, whether it's charged, the design capacity, blah, 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 current capacity. There, percent remaining. Okay, so I can do select percent remaining from battery. And my battery is at 93%. And if I have a look at, I've just put it back on power, that is in fact correct. The question now becomes, how do I do that on a schedule? Because I don't want to sit for 24 hours a day and run that query. And the good news is there is a configuration file. So if I .exit out of this and have a look at this configuration file, lots of stuff in here, but the thing that I want to show you is this schedule. So a schedule defines the queries and when they will run. This one comes out of the box, the system info, and this one I've added. And I've called it battery percentage. And this query is exactly the same query that I was running previously. And here I'm deciding to run it every 10 seconds. Yep, cool. Exit that and do sudo osquery ctl status. And actually, mine's already running. So this is the daemon that runs behind the scenes. So I can, you should do start to start up the daemon, because there is osquery I, that's the interactive one that's just a one-off query, and osquery D, that's the daemon that runs 24/7 in the background. So go ahead and start the daemon once you've made the changes to that conf file. And now the daemon will run that query every 10 seconds and log out to a particular log file. So I can now tail that log file, and it's at var log osquery D results.log. Now, there is a gotcha here, because osquery does not log if the value doesn't change. And this has got me, because if you're sat running on power at 100% power because your laptop's charged, you're not going to see any logs because you're going to stay at 100%. That's why I had to run my laptop down to 93 and, 94. And we should, as I talk, we should be able to watch this climb back up to 100%. So let's have a closer look at this. These logs. Obviously, they are JSON. And if I highlight one of them here, we have a name, battery percentage. That's what I decided to call it. Yes, we've got a host identifier, the calendar time, Unix time, the epoch, the counter, and you'll notice the counter increments for each query, numerics, false, decorations, host UID, and username, and then the columns. And this is the bit that we really care about. And there is the percent remaining, 94%, and the action is added. The next thing to notice is that you get a pair of actions. So, for example, when 94 was added, next time 94 was removed and 95 was added. And the reason is because this is actually logging the database entries behind the scenes. So basically, Osquery is going to know, well, we're currently at 94. I'm going to remove that value because now we've gone up to 95, and so on and so forth. So you can see where we're going with this. We now have nicely formatted JSON. The next step is to arrange to get that into an OpenTelemetry collector somehow. And the good news is it's actually quite simple. We tell the collector to monitor the log file with the file log receiver, and this is just start at beginning. Every time I restart the collector, it's going to reread the whole log file. I want that for this tutorial. You probably shouldn't have that because you'll get duplicate log lines. Then each log line, we're going to parse it as JSON. We're going to use the JSON parser that's built into the collector and parse the body. And we're basically telling the collector these log entries are JSON formatted. Then we need to parse out the correct time, because we don't want, when we send this to the backend, we don't want the time to be the time that the collector actually read the log line. That might be, a minute or 10 minutes or an hour later if we've restarted the collector. We want the time to be the Unix time that was actually logged. So we need a way to somehow tell the collector to grab that Unix time and make it the timestamp. And that's what we're doing here. We're saying, please look at the Unix time attribute, and that is the time. And we're using the time parser here, and we're just saying it's the time in seconds from the epoch. The next thing we want to do is get rid of these removed lines, because when we push them to our backend system, we don't care that things were removed. We care that just when things were added, because if I highlight the added there, 94, and then the next added 95, the next added 96. So we just want to see the new values. We don't care what is being removed. You might, and that's why I've put it in the collector, because there is a way in Osquery to remove, to not even log this line, but then you don't have it ever. If you ever need it, it's never logged. So here I'm dropping it at the collector layer, but it is still there in the source of truth, which is in the log file, if you ever need that. Okay, then we build up our pipeline as normal. So let's start up the backend. I'm going to use OpenObserve as always. And it's running on 5080. Yep, no data. Find out how to ingest data. Go to custom, go to logs, otel collector, and it gives you the snippet. So I will copy the snippet and I will put it into my collector YAML. And make sure, it keeps getting me this, but make sure when you build your pipeline, so we're going to receive the logs at the receiver, we're going to filter them, and then we're going to push them out to debug and the backend system. Let's open another collector window, and we need to run the collector as sudo, because the log file that the collector is watching is owned by root. So sudo tools otel call, obviously you need to download the collector binary, config equals config.yaml, and there we are. It's read the whole log line from the beginning, and you can see the body is the full JSON unchanged, and then the attributes here have already, we basically passed that JSON and pulled them off into attributes. So we've got our decorations, host ID, host UUID, and this is the main thing, columns, percent remaining 96. Now let's jump back into OpenObserve, and we've got a stream of data. That's good, and it's called logs. That's also good. Let's have a look at the logs, and you can see columns, percent remaining. Yep, 94, 95, 96. So we're going. I think I should be at 96 now. Okay. What I can do is have a look at just the percent remaining, and if I flick to visualize, and then for some reason, I think this is a bug, the y-axis counts the timestamp, which makes no sense. So I'll get rid of that, and I'll go to columns percent remaining. That's the value. I'll click add that to the y, and I'll set this to whatever the minimum value that I have seen in this timestamp for the battery percentage, the maximum. I mean, we're only doing it once, so it doesn't really matter. Let's be conservative and say minimum and run query. And now you can see that's precisely what we have. In our observability system, my battery is at 94%. Here at 7:33, it's at 95%, and then it's at 96%. And I'm sure if we should just sit and wait until it goes to 97%. Let's just keep running the query. There we go, 97%. But that's the basics of OS query and how powerful it is. You can basically find anything out about the system that you want and push it on into your observability system. By the way, this is all free and it's all open source. I hope this has been useful. As always, like, subscribe, comment. Let me know if you're using it, what queries you like. I'm just getting started with this, but it really does look pretty awesome. Until next time, stay safe. See ya.